This quick demonstration will be on structures to explain to you what structures do. The example that's given here is from the slides, and that just shows you the structure used to describe a student. So basically a structure is just a normal variable. A structure variable is just a normal variable, and the idea is that we are making our own type. What we've had in the past is that we've had integers, x, floats, y, whatever. And what we want to do now is we want to expand this to make a new type. And this new type that we're going to make, it will be a complex type. It will have various types of elements inside it. So the human analogy would be something like, for each human, you have hands, you have feet, you have different members for each human. So what we're going to do is we're going to make a variable now with different members, and each of the members will be a variable with a type. So we're making a blueprint. It's important to understand we're just making a definition here. We're not making a variable, we're making a variable type. And the way we do that is we use the keyword struct. When you do this, the computer says, your compiler says, oh, okay, I'm making a new type. It is a structure type. You give it a name, so let's call it person, and inside here we're going to explain what we mean when we say struct person. So we're defining our type here. We're giving a blueprint for our type. And what you can put in here is all sorts of members. So int x, float, y, character, c, whatever. You can put whatever you want inside this structure. So because this is just a blueprint, you can then go and make variables of this blueprint. So just as we did with this x, you said the type of the variable, the name of the variable, and then you gave it values. Now we're saying the type of a variable that we're making is struct person. It's quite annoying. You have to use the word struct here. You can't just use person. You have to use the word struct person. This is our type, and then we make a variable of it. Then we say the struct person, let's call it person1. That's our variable that we're making. Right? We can make another one of them, struct person. By the way, that's supposed to be person, and we call this variable person2. So now we have two variables, person1 and person2. And what this struct does is it says each one of these two variables, each one of them has members, and the members that it has is x, y, and c. So this in memory will be a block of memory with inside it an integer and a float and a character called x, y, and c. This is another variable, and inside this variable it will have members x, y, and c. So if I want to give it values, I can do person1 dot x is equal to 5, and I can do person2 dot x is equal to 7. Alright, so that then essentially just goes into this variable person1 and into this variable person2, get access to its x, set its values to 7. So I have two variables, and they each have their own x, which now have different values. I can do the same with y, of course, and the same with c. If you wanted to use pointers with this, you have to do something like this. You again specify the type, and then you indicate that it's a pointer, and let's call the pointer ptrp. What I can then do is I can say ptrp is equal to the address of one of these two variables that I have. So it's equal to the address of, say, person1. So now I have a pointer pointing to person1. Right. When I wanted to have access to one of the members, and I used the variable name, I used .x. If I want access to the variable name that this pointer points to, if I want access to the member where this pointer points to, I need to do one of two things. I can either do ptr p, dereference it, so go to that memory location, and then dot operate, give me access to x. So that will go to wherever ptrp is pointing to. So go to ptrp, ptrp is pointing to person 1. So it'll go to person 1, get access to its x, and change its value to 5. So it does exactly the same as this line of code does. This is interchangeable, does exactly the same. What you can also do, and this is what might confuse many of you, is you can do this using a shorthand method. Because we typically use pointers with structures, because they're big, we don't want to send them up and down and crazy, we want to use call by reference, or we want to use a reference to the structure. We don't want to use the structure name. It's easier to use the reference, so we very often have to do this. Because we often have to dereference and dot, C has a shorthand method where we dereference and dot in one go, where you say dereference and dot. This is an arrow, it's minus greater than. The arrow does dereference and dot. That does both of them at once. So when you want to work with a pointer and to get access to the member of the variable that the pointer is pointing to, then you use arrow greater than is equal to 7. So this will make person1.x equal to 7. It's the same as this here, except it's person 1, not person 2. So that's what you use when you work with a pointer. You want to get access to what the pointer is pointing to, its member x. Sorry, I forgot to put the x there. Its member x, make it equal to 7. Right, so you can access it using dot if you're using the variable name. You can access it if you're using the pointer, dereference the pointer and then dot x. Or if you want to just directly access from the pointer, pointer arrow x is equal to 7. And that's more or less it on structures.